Alright, we get the camera, we get the guy, so we're good to go. Alright. Hello everybody, my name is Nasser, mechanical engineer, hopefully. Today I'm going to talk about technology and risk in horizontal drilling. So before I start, I'm going to have an overview about natural gas industry. So why do we care about natural gas? So here's why. I think natural gas is emission-free. It doesn't get any harmful emissions to the environment, the homes and transportation. So also the technology, it's not a new technology, but here's the thing. When we first invented the horizontal drilling, it was not very economical, so we didn't use it. We couldn't use it for a commercial use, actually, for the production. And now, here days, it's happening. So, and I don't think that the horizontal drilling and shales is going to solve the unemployment problem, but it could help because it creates so many jobs all around the United States and the world. Right, let's begin. Okay, what do we see? We see this is the natural gas processing. We see the initiation, execution, software distribution. It just goes to the markets. What do we have here? I'm going to focus on the exploration, drilling, casing, a little bit about environmental aspect in the fracking process, or what's called the hydraulic fracturing. I don't have time, right? All right. So let's begin. So as a company, I don't go to someone, hey dude, what's up buddy, I want to explore a new land. This is not how it goes. This is how it goes. So as a company, I should have a contract, a leasing with the landowner. And this lease should include all of those. First, the bonus. So the bonus, an enormous amount of money. This is like, a gift from the God, actually. You're going to be rich. And so the rent is just the annual rent for any property. And in oil and natural gas world, we have something called royalty. Royalty is just a specific percentage of the production profit every year. We have, of course, the duration. Maybe we can't have a very specific estimate for how much we get to work, like how long is production is going to do. But here's how we define this. All right, after we get this, here's the next point: exploration. We didn't start drilling. Now we're just looking. So we look at the other class. We have this seismology, and I want to add one thing: the very recent technology, and this is the electrical seismology. And how do they do it? They just send electrical current into the rocks formations, and we measure the resistance in each layer, and in each layer the resistance is different. So this is a helpful information. Imaging, is just satellite imaging. We use this, in so many places for so many purposes. Samples can be like physical from the land. So how do we know how much gas is in there? How much gas? Okay, how much natural gas? And this is how we do it. We should be able to define these three properties: pressure, permeability, and porosity of the rocks. If we could be able to, identify those properties, we know, how much initially, so we can start, doing more exploration. And how do we do this? We have to generate 3D or 4D images, videos for the formation we're looking for. How do we do this? We use the CAEX. This stands for Computer Assisted Exploration. This is a technology, right? I don't know if we had this 50 or 40 years ago. So, next. In this presentation, I'm now going to talk about vertical drilling because this is not the area here. So, they get the vertically drilling and then the kickoff point and then they start horizontally. But how do they do and how deep? Well, it depends. I have an example from Marcella Shale, Pennsylvania. And what they do is they go vertically about 7,000 feet and horizontally depends on how many wells they're going to cover. Because sometimes it's just, fracturing, it keeps going horizontally. So if it goes to up 4,000, 5,000, this is what I get. It's my numbers. So this is how they do it. The main components of the directional horizontal system is a directional mud motor, and this is powered actually by the mud, and it goes down, using high pressure, hydraulic pressure, and it has, circulation all the time. We use mud and water for many things. We use them for cooling to the bit, drilling bit here, because we get very high temperatures. As more we go deeper, and we use water and mud as a lubricant to make this drilling as efficient as possible. So what's interesting here? Here's what interesting. The MWD is measurement while drilling. So this unit, this is like an instrument. It's installed inside, and it has two things. So first thing it does, it works as a navigation for this. So where to go? This is what it decides, MWD. And how does it work? It collects data about pressures, porosity, and all the stuff we need to keep going. And this is linked to the surface where everybody, engineers, geologists, are just sitting and watching what's going on. So this is how they solve the problems, in just 1 minute, if they could. I want to add one thing here. When they do drilling, these are not separate steps. So drilling, casing, cementing, they're just, simultaneously done. This is another example from Marcella Shale. This is the casing, first, second, third. First one called conductors goes to 60 feet, the other one surface, and then the intermediate. The production could go from here, from about 500 feet to the, to where the natural gas is sitting, actually. And why do we know that? Why do we need them? It's just we need to isolate the formations and the aquifer. There are some water tables here. We need to do this to isolate them from the flow zone. This is where the fluids and dangerous fluids, like fracking fluids, goes up and down. So that's what we need, and I'm going to explain why. All right, the cementing. So when we look at this, really should look at this as a whole system. We have, how many materials we have. We have cement, we have fluids, we have steel, stainless steel, we have rock. So we should look at this, and then when we design them, we design them separately, and then we see how they interact with each other. So when we design the cement and steel, temperature, density, pore pressure, these are main properties are going to go in the. So the people who done this research, they just concentrate on those properties, and they put them in thermal fluids simulation to get to get a good result. But what I see, I think that they're missing the mechanics of material part because here's the reason. So for this, there's so many materials, and as we know, the most mechanical failures doesn't happen because of the yield. I mean, the materials doesn't yield because they are well designed. But what happens is sometimes it happens, or most of the time, because of the fatigue. So what they have to do, of course, they need to add the cracks growth test. They need to test the fatigue life. They need to, to go all over this to make sure this, is very strong structure. Because we don't design for 1 month or 1 year or 5 years. We should design those properties, we should design this to last forever. That's what we do, a very high factor of safety. We don't want to lose money. All right, next. And as I said before, because life is not perfect, here's some problems happen. First, gas kick. Gas kick happens when a formation pressure becomes greater than the mud pressure. So there's imbalance, and thank you, MWD. It gets this, very quick, and it can be done, it can be solved, this problem, in 1 instant. All dimensions. Okay, the quality of the hole. The quality of the hole is a substantial thing. All the calculations should be done accurately. And here's what happened. So after we drill the hole, we get something called centralization. We centralize the casing when we install it. And as a result, this could be affected, by time. And then this make sure the process and production is stabilized. Anyways, the compatibility, however, is something different. Is how the two fluids, the mud and the fracking fluid, interact with each other. They should not. They should meet each other requirement. So this is a very important thing. And going back to mechanics of material tolerances of the casing, cement, and they should just they should be good together. Aquifer contamination. Aquifer contamination could happen if we fail to do those stuff correctly. And here's something more about this. There's a hydraulic fracturing or fracking. This perforation guns. They make the fractures. They send the fluid down. It holds the fractures to get the natural gas released. So what happened here? Sometimes the flowback water, and it's very huge. It goes back and it carries all the the stuff, the unwanted stuff. And here's what we want to avoid. So in Pennsylvania, Texas, people suffer from the water contamination in so many areas, and actually they have some problem in the drinking water because they use the water from the tap. Also, some other people have what is it? It's the reactions in the skin because of because of the methane, some leakage, from the production. Here's why. So we need to use those chemicals. So what happened if we didn't use them? Actually, the chemicals we have in the fracking fluids, they help to protect the casing because they have, in the high pressures, we have something called the skin pressures, and this can cause a lot of problems for the casing. To reduce the friction, we use one of the chemicals. Another thing is the deep inside it comes out with the natural gas is sulfur. There's high concentrations in sulfur at that. So if we allow this to happen, it's going to go just up with the flowback water, and it's going to affect the environment. So we keep this chemicals to take care of this and to reduce. It's not 100% removal. It's reduction just in the sulfur concentrations. All right. Here's more about this. I found this video.
One of the things that oil companies and gas companies and geologists always kind of use
She's gonna explain just the process of fracking, but
kind of
here's
gas in, say, Pennsylvania than it is to drill the oil off the coast of Louisiana.
All right, this is a very interesting video. I think you've seen it before.
Whoa, Jesus Christ.
This is the image that people know of about fracking, right? A drinking water tap catching on fire. That happens when you have methane in the drinking water. So what you hear from advocates, environmentalists, folks who live near there is that the drinking water is contaminated either because there's natural gas in it or because those chemicals that are being used to kind of push the fluid down into the rock, fracture it, that could seep into groundwater. A lot of these chemicals are dangerous, but we don't quite know exactly what's in it because nobody requires the companies to say exactly what's in it, and they say that if they told us the secret ingredients, that would put their business model up.
So here's some recommendations for this. Looking at fraction fluid structure should be allowed at least, at some areas, residential areas. Never dispose flowback water without treatment. Treatment is there, but it's partially. They don't treat all of this because it costs a lot. Improving water recycling so that they could reuse the water for fracking again and again. Right.
This is the central.
I think this is everything. This is, when I found out that we have this horizontal drilling technology, back home, very long time. It's just, I was surprised, and Any questions? Okay, no questions, so see you next semester. Thank you for listening. All right, this is 17 minutes, that's perfect. Oh, well, it's not perfect, maybe.